Thanks guys for joining. My name is Raja Rao. So today's agenda, it's kind of divided into three sections. In the beginning, I'm going to talk about what Node.js is all about and what the buzz is around it and what kind of apps are being built and stuff. In the second section, I'm going to talk about coding in Node.js. I'll be showing some of the differences between synchronous programming and asynchronous coding, classes and modules, npm, package.json, and stuff like that. In the last section, I'll be doing a lot of demo apps, where I'll be pushing basically 4 different apps that kind of shows you the power of Node.js and how easy it is to use it on Cloud Foundry. So with that, let me start with what is Node.js. Node.js is basically a platform that allows you to build fast and scalable network applications. It is built on Google's Chrome V8 engine and implements event-driven non-blocking I/O model. So if you don't get anything right now, don't worry about it. I will explain everything in detail. But basically, Node.js allows you to build server-side applications. So throughout this presentation, throughout this talk, think of yourself as a server-side developer. Don't think of yourself as a front-end developer or something, just because we are using JavaScript throughout the session. Again, Node.js is actually built, if you look under the hood, it's actually like 80% C, C++, and it uses CommonJS module system, which kind of helps make your write, your JavaScript code and organize your JavaScript code very easily, and it essentially executes JavaScript on the server. It's not built using JavaScript; it just runs JavaScript. And it was actually created by this guy Ryan Dahl, and it is sponsored by Joanne. So just to give you a little bit of an idea of what Ryan Dahl did was it created this simple graphics. So on the left-hand side, you have a browser, as you guys all know, so it can run JavaScript. So if you are using a Google Chrome browser, it has a JavaScript engine called V8 engine that runs inside the browser. And this browser obviously runs on your laptop or your desktop, and which is technically speaking a local host. So what Ryan Dahl did was to take the JavaScript engine and added HTTP, TCP, DNS support, and also added libuv support, which is event loop, and added, in addition to that, added several JavaScript libraries so that it helps developers like you and me to write JavaScript, to write server-side code very easily. So, and he called this whole package, this whole platform as Node.js. So now, because it has the JavaScript engine on the server, you can just directly run it on the local machine. You can basically create really powerful and highly scalable servers, and it provides a very straightforward interface for you to write your server-side programming in JavaScript. Although these HTTP, TCP, and DNS support and libuv and all these modules are all written in C++. So Node.js is mostly C, C++, but it runs JavaScript. Okay, so what is the biggest thing that Node.js brings to the table? So apart from allowing developers like you and me to write server-side applications in JavaScript, the biggest thing it brings to the table is savings in I/O cost. So I'm going to explain how it does in the future slides. But let's take a quick look at the I/O cost. So anytime you're writing a server-side app on the server side, and whenever some user comes in from a browser or some other mobile applications or something, your server will end up doing some kind of an I/O. It might be doing, it might be going to the cache, or it might be going to the disk or a network. And whenever it goes and tries to get some information, some data from this cache, you can see how much time a CPU waits while your application is actually doing this I/O. So if from this chart, you can see that if your application is talking to a L1 cache or L2 cache, your CPU is waiting for 3 cycles or 14 cycles. But on the other hand, if your application is doing a disk I/O, your CPU then basically waiting and wasting like 41 million cycles by the time the I/O happens. And if your application is kind of let's say a proxy to Twitter or something or Facebook or something, then you are making a network I/O. In that case, your application ends up, your CPU you'll end up waiting for like 240, 250 million cycles, without doing anything. So what Node.js does is you have to make sure that it doesn't, your CPU don't get wasted. It kind of implements this thing called event-driven non-blocking model in order to save the I/O cost. So I'm going to kind of explain what exactly it is by comparing a simple a multi-threaded server, which is it does a blocking I/O, and also a event-driven non-blocking server, just so that you can kind of understand what it is. So let's take a multi-threaded server. So whenever a user comes in and he makes a request, let's say login, then the multi-threaded server will spawn a thread, and which makes a request to database to see if that user is legitimate or if he should be allowed or not. But this particular action is blocking I/O. So at the same time, if other people come in and try to log in or try to do some kind of interaction with your server, then all of a sudden the multi-threaded server starts to spawn more and more threads to support all these individual requests. So you can see here, let's say the fourth user in this diagram is refreshing his browser, maybe because he's not getting the request soon enough. Then all of a sudden, the multi-threaded server will start spawning more and more threads to support all these concurrent users. So on the other hand, let's take a look at how the Node.js server's architecture is. So Node.js server has two parts to it. So it has the front part, which is like a event, which is what we call as an event loop, where your Chrome V8 engine runs, and then at the back end you have a POSIX thread pool. So there are like several asynchronous thread pools that are kind of waiting there for work to be done. So to give you an analogy, it's almost like you go into Starbucks coffee, where there is a person at the front who takes your credit card and asks what kind of coffee you want and stuff, and then when you say, okay, I want latte, that person doesn't go and then make the latte himself. Rather, he goes there and he asks some people at the back to go and then prepare coffee for you. So that's how the Node.js kind of architecture works. So let's take a look at what happens when a request comes in. So whenever a user makes an I/O request, so this front thread, the V8 engine, will receive that request, and immediately it will delegate that I/O request to the POSIX asynchronous threads at the back. So it doesn't really respond back it doesn't really do the I/O itself. Rather, it always delegates it. And doesn't matter how many requests comes in, it keeps sending the request back to the POSIX threads at the back end. And along the way, at some point in time, as you could imagine, the backend server the database will respond with a response. And whenever the response comes back, it doesn't really immediately get executed, but at some point, its thread, the response's turn comes in, and that gets executed, and then you get the response back. So that's how the whole architecture works. So except your code, the code that you are writing in JavaScript, everything else actually runs in parallel, except your code, because the event loop, the V8 engine itself is a single-threaded one. So one caution that you need to take is, one thing that you need to worry about here is, because it is single-threaded, the JavaScript itself is single-threaded, you need to make sure that your code runs extremely fast. So if you have, let's say, some kind of a while loop or something that takes a long time to finish up some function, then the Node.js will basically halt. It won't allow others to it won't serve any other request. So I'm going to quickly give you a real-world example of the two architectures, so that you guys can kind of understand the benefits and the drawbacks of it. So I'm using an Apache server, which is a multi-threaded blocking server, and then Nginx, which implements an event-driven non-blocking model. So if you take a look at it, this is a performance chart. The orange one is in Nginx, and the blue is in Apache. So if you look at the extreme right here, at around 4,000 concurrent connections, you can see Nginx could serve up to 9,000 requests per second, whereas Apache could only serve up to 3,000 requests per second. This is mainly because of the model, the difference in the model. And then if you look at the memory usage, so you can see that again at 4,000 concurrent connections, Nginx, which is in green here, is only using 3 MB of memory, whereas Apache is actually using 40 MB of memory. That's like 12 times more memory than Nginx. So that should give you an idea about the performance and the memory usage just because of this design or the architecture difference. So now I'm going to show you I/O is great, but what else is happening with Node.js, right? So I/O is great. You can write stuff in JavaScript. You can write the servers in JavaScript, but you also want to know what's really going on with Node.js. So let's take a look at the communities, libraries, and stuff now. So if you look at the GitHub's most watched, you can see that Node.js is actually second most popular watched open source project. It's only behind the Bootstrap, which is more like a front-end library. Given that it's only 3 years old, you can see how much you could imagine how much popular it is. And also, let's take a look at the libraries. So I can say that, hey, you should all write everything in Node.js, but if there are no libraries, then you can't really go and then actually build applications. So this slide, I kind of keep it all the time, is actually I created about 3 months back, and it shows about 8,000 packages or libraries for you to use. But in reality, let me switch back here. Give me 1 second here. All right, so in reality, as of today, there are actually 12,000 libraries. So 2 weeks back or 3 weeks back, we had this conference for Node.js called NodeConf, where the head of Node.js, the engineering head, Isaacs, mentioned that last year at this time, we had about like 2,000 libraries. As of today, it's gone up to 12,500. So that's literally about 10,000 more libraries in the last 1 year. So that should kind of give you an idea as to how much popularity, how big of a deal Node.js is becoming. And when you talk about libraries, what kind of libraries I'm talking about? They are mostly like routers. You have libraries to connect to databases. There are libraries to connect to do XMPP, RPC, WebSockets, templating. You can think of anything. There is one. So what kind of things people are building? People are basically building, and what kind of apps are people building, and who is really using it? So Node.js actually, although it's only 3 years old, a lot of the big guys, surprisingly, have embraced it like 2 years back itself. And now it's in production for more than a year. Some of the names are LinkedIn, Yahoo, Yammer, and of course even VMware. We are using it within Cloud Foundry, eBay, and Twitter. So they're all using it for one reason or the other. Yammer, if you guys know, was recently sold to Microsoft for $1.2 billion, and they were at NodeConf 3 weeks back, basically mentioned that Node.js was one of the primary reasons for their success, because it basically gives you very fast iteration. And so what kind of other interesting apps people are building? People are building lots of end-user apps, like you could imagine real-time apps, mobile apps, websites. And the funny thing that I noticed, again, was that a lot of people are doing hardware programming, where they're controlling robots and sensors and stuff using Node.js. This is very interesting. I highly encourage you to check out Node.js and hardware programming. And the other thing people are building are platform apps or services and servers, like HTTP proxy. There are people who are building these TCP servers, like LDAP.js. So this LDAP.js is a LDAP implementation that's completely written in JavaScript, in Node.js. And SMTP, there is a SMTP implementation in Node.js. There is XMPP, SSH, RPC. So you can think of any protocol or any kind of services that your apps might use. There are people who are building or already built services using purely Node.js. All right, so that brings us to second section, which is coding in Node.js. So I'm going to kind of quickly go over some of the differences that you might encounter whenever you're doing programming in Node.js. So I'm going to first start with synchronous code versus asynchronous code. So on the left-hand side here, you can see a simple synchronous code. So I'm going to kind of go over them step by step. So there is a function called get item name by ID. So this function simply takes the ID and returns a name. So in step 1 here, I'm calling this get item name by ID. And this function, when the function call is done, it goes to the database, and then here the DB is saying db.get and for that ID. So it is trying to retrieve the name in step 2. But then this is a step what we call as like a blocking. So this is where blocking happens. So until the DB responds, you won't get any response back. And then once the DB responds, you can basically print out the name that you got here. So whereas in asynchronous code, it's kind of it's a little bit different. So the way the asynchronous code works is there is no such thing as a return from any kind of an IO. So if you are making a call to a database or a file system or a network, there is no such thing as return. But rather you will create a kind of a helper function called callback functions. So in this case, we have a helper function called display helper callback. So what you do is you kind of reorganize your code where any kind of typical code that you have, like this one on the left-hand side, so you add another parameter where you can pass this function. So again, remember the Starbucks analogy where you go and then you ask for, hey, make me a latte, and then the person who took the order will then delegate that work to someone else. And when the coffee is prepared, they will call you back. They will say, hey, Raja, your coffee is ready, or who is Raja? So that's the callback. So, and then you go and then you receive the coffee. So the same thing happens in Node.js. So every function that kind of does any kind of a IO, all of them require you to pass a callback, which is where you say your name, in the Starbucks analogy. So here I'm passing the same, it's very similar to the function that we saw here, but in addition, we are passing the name, where should the return, the response to be called back. And so we are passing this callback function, and then this step 1, and in step 2, so this function here makes the same db.get callback, db.get request, and again passes the callback to this function, this internal function. But you can see there is nothing is returned here. There is the control doesn't come here at all. So step 3 actually happens in the internal to in one of these DB libraries. And whenever the response comes back, at some point the response will come back, and whenever the response comes back, this particular function, this callback function, will be called. So I'm going to go a little bit details into exactly what happens. So by taking the same example that I showed you earlier. Again, you are making this get item name by ID function call, and you are passing the callback in step 1. So and then the request goes to the db.get, which is a library, and you are again passing the callback here as step 2. And after that, so you can see here, this is a DB library. So this is just a high-level DB library. So you can see here this DB is making the network connection. It's making a TCP connection to the database server itself. And in step 3, when you make a call here, db.get, it comes here in step 3. Ignore this one for now. But what happens here is it's saying, hey, connection, get me read the value for this ID. And then there is another function right here. So one thing you should remember while you're coding in Node.js is there will be lots of callbacks, and there will be callback. We call it as it kind of goes by the name callback hell, because there may be a function that is receiving a callback, and then there may be another function like what you're seeing here. So this is the outer function that is receiving a callback, and internally it is making a call that again expects a callback right here. So, but then there are lots of libraries and stuff that will help you ease this pain. But again, every function that that is returned that kind of makes or involved in an IO always take a callback function as a second parameter. Or there is also something called event emitters, which I'll talk about in the future slides. So those slides. So in one way or the other, you kind of always have to pass where the response has to come back. So step 3, you make a request to database, and you're saying, okay, call me back. And after step 3, the control actually goes out. So from this point on, the Chrome V8 engine will not wait for you for the response to come back. But instead, V8 is free to run other functions. It may be serving someone else, or it may be doing something else. So let's say, for example, step 5 to step 100, it is serving some other people. And at some point, the response from the database comes back. But again, let's say it was step number 101. At 101, the response database said, hey, this is the value for the ID that you were asking for. So at this point, the V8 engine will start executing your callback that you passed here. So at step 101, it actually calls your function. And here you can see this DB library is saying, okay, callbacks, run this callback that was passed earlier to me, which was here. So step 102. And then at step 103, it comes back to your program, which you wrote, where this particular console.log will be executed. So although it looks like there are only 3 or 4 steps at a high level, but if you look closely, there may be a lot of steps in between, where the idea is whenever you are making any kind of a actual request, the V8 engine will go out of your code and control flow, and then it will start executing someone else. At some point, it will get the response back, and it will again come back and join the control flow. So it kind of goes out and then comes back. Hopefully, you guys are following how the asynchronous code works. All right. So let's see. Next thing is how do I better organize my code? So one of the things that people see whenever you are thinking about JavaScript and Node.js is that because it's a functional programming, how am I going to organize the code? But even though JavaScript is functional programming, it provides a prototypical inheritance, as you might already know. So you can very easily create a class, although it is called function. You can create a class, in this case automobile, and then add a method, in this case get model, and then you can subclass it. You can create a subclass called car, and you can very easily inherit this car class from automobile class using a function called util.inherits. So this util.inherits is simply a helper function that is provided in Node.js. But the main idea is, the reason I'm showing you this is most of the people who write libraries inside Node.js use this util.inherits function. So once you created these classes that I showed you, you can very easily organize them in separate files. So you don't need to keep them in the same file. So here there is a JavaScript automobile.js file, and there is another file, cars.js file. So now, if you want to inherit so this class, automobile class, from car class, all you need to do is to say require and the path to this automobile. And once you do that, you can very easily start, it's the same code, but it's now in 2 different files. So the reason you can do all these things is because Node.js implements this thing called CommonJS module system. So CommonJS module systems allows a JavaScript written in one file to be exported by using a pattern called exports.name. So here you can see I'm exporting the automobile class, saying exports.automobile. And then whoever is importing in the left-hand side here, so you can say require and the path to this module. So you can simply say require an automobile.js, and then from that point on, this is as good as these 2 functions are in the same JavaScript file. So you can also export multiple things. So if you are one JavaScript file and you have multiple things that you want to export, you can simply say exports and give a name for that, and you can export an array, you can export variables. So you can export anything you want. You can even export multiple items. And again, in the importing file, you can say require this JavaScript file, and from that point on, you can start calling these items or using those variables or arrays as if they are in the same file. So another thing is called CommonJS modules also provide this thing called exports and also module.exports. So module.exports is basically you want to use when you have only one thing to export, and you kind of encapsulating everything inside that. So the main advantage of this module.exports is that you can when you require it, when you import it, you can directly use that as if it's written. You can directly use it as a function. So next thing I want to talk about is npm. So npm is a node package manager, which is basically a command line tool that you get when you install Node.js. So at this point, I'll go back to the place where you can download it and stuff. Let me quickly show you that. So before we get started, I want to kind of you can go to nodejs.org and then download Node.js. The cool thing is Node.js comes with even in installer, so you can, even if you're on Windows or Mac, you can go ahead and then install Node.js very easily. On Linux, you can even use Mac ports and others to install it. So, but when you install Node.js, you get two command line tools, command lines that you typically use. One of them is Node, and the other one is npm. So I'm going to talk about npm right now. So npm is the one that allows you to download all those libraries that I talked about earlier. So there are like 12,000 or so libraries, but you want to use them, right? So you want to download them. So npm provides a way to easily download them. So there is a library called Express, which I'll be using later in the presentation. So if you want to download and install that and use it in your application, all you do is npm install Express. So whenever you execute that, it simply installs that in a whatever your folder was, your application name, and it will install it in a node_module/express folder. So you'll find it in node_module folder. And there is also another thing. So a lot of these libraries that I talked about has some of them comes with executables. So for example, Express provides some executables where you can very easily create applications like bare bone applications out of it. There are many other frameworks, web frameworks, where they allow you to create a hello world applications very easily by running them as executables. So, but in order to do that, you need to install it with a flag -g, which is a global way of installing it. So when you do that, it will install the library in in user local Node.js node_modules folder, and it will also install a executable inside user local.bin folder. So the reason you would use -g again is to you make use of any executables that might come with this library. So not all libraries are just JavaScript libraries. So some of them have .sh files in it, so you can very easily execute them. So one other thing I want to talk about is very important is package.json. So like I showed you earlier, you can very easily install your library using npm install express. But a lot of times what you want to do is to say npm you don't want to like do npm install express, npm install socket.io, npm install mime. So you don't want to do that for every single library that your app uses. And secondly, if you do it that way, then you cannot really share your code with your coworkers, because then they will also have to do that, and also the versioning problems. So all these Node.js libraries comes with various versions. So, and the version keeps increasing. So if you don't have a proper mechanism, then it's going to be hard to share these libraries, what version to use and stuff. So there is this thing called package.json with that kind of alleviates all these problems. So all you need to do is create a package.json file in your application, and inside that you can then describe your application. Application's name, the version, who is the author, and in addition you can describe all the dependencies. Okay, this particular app depends on Express, and you can give the exact version. You cannot, if you don't provide any version, it will download the latest and greatest version. You can also do things like, okay, I want version that is greater than or equal to this, or less than this. So you can do all these cool things. And now, once you have this package.json, all you need to do is npm install, And whenever you do npm install without any module name or anything, it will read this packet.json, and then it will install all the libraries that was described in packet.json. Okay, so next I'm going to, so before that, let me quickly show you some of the Hello World applications. I've been eager to show you guys. See. So, since by now you might be wondering, how does a Node.js application even look like? So this is a very simple Node.js app. So the main thing is, like I showed you, talked about earlier, so there are lots of libraries that comes with Node.js itself. So you can simply say, one of them is HTTP, so you can simply say require HTTP. And the other thing is, in this case, once you require HTTP, you can very easily create a HTTP server. So to do that, you say http.createServer, and again pass a callback. So here, in this callback function, what you're saying is, hey, if someone connects to me, then respond back with hello world, and I'm running on this host and this port. So this host and port are assigned here. So on the left-hand side here, these two variables, ignore these two things for now. But the main idea is you're saying, okay, I'm going to run on this port, and I'm going to run on this local host. And these two variables are actually environment variables for Cloud Foundry. So if you're not running on Cloud Foundry, then you would only need this. But if you're running on Cloud Foundry, you would need this. So what it does is, what it's saying is, if you have process.env, which is an environment variable, and if you have such an environment variable, and if you have vcap app port variable, then use that port rather than 3000. Because in Cloud Foundry, we don't allow you to have this kind of a static port or static host. So that's why you need to kind of create this kind of if-else condition here. So I'm going to quickly show you how it would simply run on my local host for now, and I'm going to show you how you would push it to Node Cloud Foundry a little bit later. So once you have that, I can say app.js. So now I can go to localhost, and you can see that it is running on localhost 3000. So that's all what I wanted to show you right now. I'll be showing you a lot more details a little bit later in the third section. But before that, I want to quickly talk about this elusive thing called, a very important thing called event emitters. So event emitter is just a JavaScript class within Node.js, and it provides two important APIs that you will be encountering as you are dealing with Node.js. One of them is called on, the other one is called emit. So one thing to remember is you would use event emitter when you're creating a asynchronous library, not when you're using it. So let's say, for example, if you are writing a MySQL database library itself, so you are actually authoring it, so then you would use this rather than just using a MySQL library or a MongoDB library. Okay. So I'm going to quickly explain how this event emitter works. So event emitter has a kind of a hash map here. It's called event name and callback list. So callback, like I mentioned earlier, is just a function, that helper function. So it kind of keeps track of events, which is basically a string, and then a callback, similar to like something like this. So it will have a list hash map that will look like this. It will say event 1 and callback 1, callback 2, event 2, callback 3, callback 4, etc. And it provides these two APIs, like I mentioned earlier. So the on API. So the on API allows others to add callback function for an event. Okay, so this is if you don't understand anything, all you need to remember is this on API. Don't worry about the emit right now. Just worry about the on API. So on the left hand side, the first parameter is event name, which is just a string. You can say on error call this function. So you will be using a lot of on functions while you are dealing with Node.js code. And internally, these libraries will have this thing called, like I said, if you're writing a database library, they will have this thing called emit. So those, whenever the response comes back from the database, for example, this emit function will be executed internally. And what this emit does is it goes through this callback that we showed here, and it will simply look through all of the callbacks that are here for this particular event name, which is here, and then it starts calling each one of those callbacks. It starts calling all those people who are waiting for this event. So I'm going to show you a little bit more, explain it in a different fashion so that it gets, you can understand it a little bit better. So let's say you are writing a database library. So, and you are writing a read from DB function, which basically contacts the database and reads the result from the database. So you can solve it, now, but the problem is because the response is asynchronous, you don't know whom to send it back to. So it's almost like you are preparing a coffee in Starbucks, but once you're done with it, you wouldn't know whom to call back, whose name it is. So you need a callback. So you need someone to write who the response should go back to. So what you do is, in Node.js side, what you would do is you kind of say, okay, I want events, and then what you do is you say, I'm going to write this read from DB function, and I'm going to emit a data event. So whenever I get the response, I'm going to emit an event whose name is data, and I'm going to return the data that I got from database. And then what you say is you go and then in your docs or in your libraries, you go and tell it to everybody that, hey, if you guys want to use my library, then you need to implement this data event emitter. You need to listen to this data event. And then the person who is using your library will go and then he will use your module, your database module, and then he's going to say on data, call my function. So this is how the person who is using it will use the on API. So whereas you would say emit. So you're going to emit data whenever the data response comes back. The person who is using it will say, I'm going to use on, and then I'm going to basically register my callback, where I say, whenever data comes back, call my function. So the other thing to note is, most of the libraries in Node.js emits errors, can emit multiple functions. So it can emit error, it can emit connect, disconnect. So if you're dealing with a database, so if you are dealing with the database functions, or if you're dealing with any kind of I/O functions, so then you should expect there are a whole bunch of events being emitted by these database libraries. Okay. All right. So I'm going to show you a little bit more about why this thing works. So another thing that you might encounter when you're dealing with Node.js. So this is called events or exception handling. So at the top here, you have a function where you have a try-catch block, and you're saying database connect. So connect to the database. And let's say something happened. Let's say the database was not running. There is some kind of a connection exception. So you would expect this catch block to throw this console.error if there is an exception. But that won't happen. Because again, remember, this whole, anytime you're doing a connection to database or connection to file or network, it is an asynchronous thing. So what happens is the V8 engine comes in and then it says, oh, I need to connect to database. Hey guys, take this out to the to the thread pool and say, you guys connect. And then it moves on. It won't even catch the exception if something happens. So that's why what you need to do is you need to say, you need to use something called as again the event emitter. So you need to say use the API on API. So you say on error, call my function. So you need to pre-specify what should happen if database does not connect or connected, or if it is connecting or if it is reconnecting. So there are a whole bunch of events that you could use that the DB will expose you to. So if you go through the documentation, there will be a whole bunch of event names. So that's something that you should get comfortable with. So there are a whole bunch of events names. So you can go to any library, there will be like 15 events. They will say, okay, if you are using my library, you need to think about these events. So in this case, for example, there is an event called error event. So if there is an error event, you pass what function to call. So you are saying, okay, if the database doesn't connect, then call this function. So that's how you deal with this. Again, there are 2 or 3 patterns that you need to remember when you're dealing with Node.js. But once you are kind of comfortable with those things, then it should be very straightforward. It's kind of the same thing when you're dealing with functional programming, and then you go to object-oriented. You need to do a little bit of a mind shift. You kind of have to think a little bit differently. The same thing happens when you are coming from a synchronous programming world to an asynchronous programming world. All right, so that's pretty much some of the high-level things that I wanted to talk about. Again, remember, most of the functions will take callback as second parameter, and then remember about the events. So the whole Node.js, all the libraries are written from ground up to be asynchronous. So every library, if you go to MongoDB library or take a look at any MySQL library or a RabbitMQ library, Redis library, anything, they all have events. So they won't have like a try-catch thing that I was talking about earlier. All right, so that brings us to part 3, where I'm going to do a few demos. So before that, I'm going to quickly talk about Cloud Foundry. Just a quick intro to Cloud Foundry. Cloud Foundry is an open platform as a service. So the main idea is we want to kind of empower developers to basically focus on their source code and design and getting the people to use their app rather than dealing with all the DevOps like infrastructure as a service. So what we are focusing on is simplicity and openness and flexibility. So our app, when I'm going to show you some of the commands that we'll be using to push even the source code to Cloud Foundry, it's very, very simple. And it's extremely easy to use. And it is open, and there is no vendor lock-in, which basically means if you're writing something in Cloud Foundry, there is really nothing that is proprietary, where at the end of the day, let's say a year from now, if you decide to move out of Cloud Foundry, you don't need to do a lot of hard work to move it to some other cloud. We hope you don't, but we don't want to lock you in though. And we also provide a lot of flexibility, and it's very flexible and scalable. So you really, to go from one instance to 100 instances is really a matter of seconds. And if you look at our Cloud Foundry's source code, it's very modular, and it's very flexible. So if you want to add something to it, so you can very easily go in and add to it. So at a high level, we kind of have this triangle which shows you what Cloud Foundry offers. So we offer a whole bunch of frameworks: Spring, Scala, Node.js, Ruby, Lyft, and a whole bunch of them. And open source community has added Python support, .NET, Erlang, PHP support to it. And we also provide lots of services like messaging service, like RabbitMQ, and database service, like databases and stuff, like MongoDB, Redis, MySQL, and vFabric, Postgres, of course. And the third one is we provide various ways for you to run your applications in various clouds. So we provide a private cloud, public cloud, and also we have a micro Cloud Foundry, which is a Cloud Foundry on an USB. So the main idea is we don't want to lock you in. So we provide a lot of tools for you to run your source code however you want. Okay, so I'm going to quickly go over a few demos of Node.js and Cloud Foundry. So earlier today, I showed you how to run a simple Hello World app on my local host. I'm going to show you how to push it to Cloud Foundry. So one of the things you note here is, like I was mentioning earlier, the process.env variable will contain all the environment variables. So one of the things is vcap app host and vcap app port. So these two variables will contain host and port information for your application. So So what happens is when you push the source code, it automatically Cloud Foundry will automatically inject these information to your application. So you don't have to worry about, how do I get it? So Cloud Foundry will take care of that. So let me quickly push this app into Cloud Foundry now. So before that, I want to quickly show you something called VMC. So I'm using a tool called VMC, which is a simple Ruby-based tool that you can go to cloudfoundry.com and download. So it's a simple command line tool. So all you need to do is go to Cloud Foundry and get started, and you have all the steps here to get it installed. There are other ways, like we have a Eclipse plugin. You can even push it from Cloud9 IDE, and there are various other ways for you to push your source code. But I'm using a VMC tool. So in order to push your source code to Cloud Foundry, what you do is, beforehand, what you would do is VMC target API.cloudfoundry.com. So this will target to our hosted environment, and then you log in. So since I've already logged in, I'm not going to show you that. Then what I'm going to do is I'm going to push it. So I'm going to say push. So I'm going to give a name called Node 1000, and it's asking me should I upload it from the same directory. Yes, it already detected that it is a Node.js app, and this is the URL where my app is going to run once it starts running. So how many instances? I'm going to say 1. Bind to any existing services? No. So I'm now going to run. I have now pushed my simple app to Cloud Foundry. So if I go back here, so if I open that, so you can see it is running on this host and this port. But now it's very easy to scale up. So I can say VMC instances 1004. So I want 4 instances. So immediately it is scaled up now. So you can see if I refresh, you can see different hosts and different ports. Because data center is a multi-tenant, and some of the instances might actually be running in completely different virtual machine. So not everything will be running on the same virtual machine. Some of them might run on the same virtual machine but different ports, but that's how the whole architecture is. So the next thing I'm going to show you is how you would connect to services. So like I said, when we say service, we basically mean like databases and message services and stuff like that. So one of the databases we support is MongoDB, and one of the things that you could use, one of the libraries that you could use to easily connect to MongoDB is called Cloud Foundry. So you can say require Cloud Foundry, and it provides you a easier way to connect to MongoDB. So again, can you guys hear me well?
I'm not going to be able to answer.
Okay. All right. So I'm going to assume that you can hear me, but then I'm going to continue because we are kind of a little bit short on time. Okay. So the main idea of this module is to simply allow you to easily get this hostname, port, username, password of the MongoDB. So now again, if you are wondering how you would get these things, so when you push your app, I'm going to show you this. When you push your app and you say I want MongoDB, Cloud Foundry will inject all these information to your application. So you don't need to worry about it. So it's already there in an environment variable. So this library simply makes it a lot easier to retrieve those things from environment variable. All right, so I'm going to quickly show you this app. Come back here and show you what it is. So in this case, I'm using a runtime called Node.js. Just for your information, as of last week, we started supporting Node's latest version, Node.js, which is 0.8.2. I can actually show you this. So you can do VMC runtimes. So you can see all the runtimes that Cloud Foundry supports. So we support Ruby 1.8 and 1.9. Node 0.4, 12 is the default. 06 and 08. Java 6 and Java 7. These are the runtimes that we support. So you can also see, so if you do VMC frameworks, you can see all the frameworks that we support. Like we support Rails, Node, Sinatra, Java, Lift, Play, standalone apps, Grail, Spring, and Rack. So we are kind of constantly adding support to various frameworks. Let me go back to this VMC. So if you want to use any of these runtimes that are not default, you would say -- runtime and give the runtime name. So this is for Node, I think for Node 082, the name is Node 08. So you would use that. Detect Node.js application. So it's going to be running here. How many instances? 1. Bind to existing service. Yes. So I already have a service called MongoDB 1, so I'm just connecting to that. And I don't want to bind to anything else. So I'm going to say yes just for a second. So this last one is saying, do you want to save this configuration anywhere? I'm going to say yes. Now it's uploading MongoDB. All right, so now it's there in, what's the name? Okay, so this is my app. It's a very simple app. All it does is it simply creates a random user, and if you refresh it, it gets the top 10 users from MongoDB, back from MongoDB. So let me, before I forget, let me show you this thing. So one of the questions when we are uploading was, would you like to save this configuration? So I said yes here. So what it did was it actually created this file called manifest.yaml file. So this file, as you can see here, is almost like a package.json file for Node.js, but for Cloud Foundry. So here you can describe what your app's name is, what kind of version you need, what kind of services you would use, and all those things in this file. And second time around, if I actually push it again, then you don't have to answer any of the questions. So it will basically read this YAML file and then take care of configuring everything for you in one step. So, and also if you are wondering how the this is a web application, right? How it looks like. So you can see this is my simple JavaScript, the Node.js app. This is the main app, and I have a view. It's a EJS, which is simply a templating file. So this is essentially a HTML file, but it allows you to pass some of the parameters, so you can very easily insert those information into this HTML file. And I have a public folder here. This is where I'm keeping all my JavaScript. And this is the Node modules. As you can see, I have Express, MongoDB, and Cloud Foundry, and all these Node modules that I would need. And I also have a package.json. So here I have described what my app is, what dependencies of my app is, and all those things. So this is how a Node.js typical web application looks like. So I just want to quickly show you, I think we might just run out of time by 5 minutes. Hopefully that should be okay. So I'm going to quickly show a few more things here. So if you're dealing with MongoDB, the main thing you need is you need to construct this URL where MongoDB : username, password, host, port, and DB name. So that you would get all the information from here. So once you do that, again you can see the pattern here. You have the function. This function is the one that is adding the user. When you click the button, so it gets the username, and again there is a second parameter, is a callback. And then, and before that, when you make the connection, it actually is stored in a variable called conn variable. So to this variable, if you are familiar with MongoDB, in MongoDB, it's a NoSQL database, so everything is like a collection and documents. So think of the rough analogy for MySQL users is like a collection is more like a table, and each document is more like a row. So here I'm creating a users collection, and I'm going to say, okay, whenever grab me the users collection, and when you get the users collection back, call this function. So this green one. So, and at some point the user collection will be retrieved, and then you are saying, okay, insert this user. And again, you want to know whether the user was actually inserted or not, right? So I'm not showing the errors here, but again you say, okay, insert it asynchronously and call this function when you're done. So you can see there is a function and inside a function inside another function here. So this is what we call as a callback hell, but there are modules called step and async. So there are many modules, libraries that you could use to kind of clean up this code. But right now I'm just showing you how it would work, how it would look. So next thing I want to talk about is Express. ExpressJS is a web framework that's inspired by Ruby's Sinatra. So the main idea is it provides you kind of a starting point for you to write your web applications, right? So you want to kind of start somewhere. You don't want to redo everything. You don't want to rewrite everything. So it kind of provides a support for configurations, routing, templating, sessions, and many features. It has a lot of features to it. So if you're starting with it, I highly encourage using Express. So I'm going to quickly talk about some of them. One of them is middlewares. So middlewares are simply functions that you could use. But before that, the way you would start using Express is you say require Express. And you say express.createServer. Very similar to how we did http.createServer, you say express.createServer. And once you create that app, you say express.use logger. So this function basically logs whoever hits your web application. So you don't want to rewrite this logging, right? At the same time, there is another middleware called static middleware, to which you can provide a folder. You can say this folder is public files, where you can keep all your JavaScript, you can keep all your CSS files and HTML files and stuff. And there is another middleware called body parser. So this allows you to your application to easily get all the HTTP post body, whatever is being sent in the body, and also any of the request parameters. Again, middlewares are simply functions that intercepts any kind of a web connection, HTTP connection, before your app gets it. So before that, it's kind of in the middle. So this is the one that kind of parses any request, and then it does something with it. The second one is environment. So Express provides configure API, so where you can configure development and production. So you can say, hey, if I'm in production, then use the logger middleware. But if I'm in development, I don't care about logging all the hits because it's a development environment. And then the routing. So you can very easily do the routing. You can say, if you are building an API, a RESTful API or something, then you can say get, this is HTTP get. And if you want to do HTTP post, you can say /register, and app.post will basically go, if anybody posts to /register, will go to this page. I think it's already 11. I'm going to go over for 5 more minutes just to show you one more demo. I'm going to skip this demo, but you can get to this Express a little bit later. I'll give you a GitHub URL. But anyway, the Express app was just like this. A very simple web application. It has a username and login, and if you use the correct username multiple times, then it would show you too many logins. If you use incorrect logins, it will show you too many logins because it uses sessions. So, sorry, I won't be able to cover that right now, but I'll skip to another very important one. But if you use a real proper username and password, it will use a session to know exactly which user is and stuff. All right, so the last thing I want to talk about is Socket.io, because one of the neat thing about Node.js is it is very fast. So a lot of people are using building lots of real-time applications like Twitter, Facebook, or chat applications or RPC using Node.js. So one of the modules that you could use to build a real-time application is Socket.io. So all you need to do to use it is simply say require Socket.io, and you, for your Express app, you can say Socket.io.listen. So Socket.io has essentially two pieces to it. So unlike most libraries where everything resides in the server, it has a server piece and a client piece. I'm going to talk about the server piece first. So when you import Socket.io, it provides an API called connection. So on connection, what you can say is you can say socket.on. You can make up any event name on send chat. Then here I'm saying whenever someone sends a chat to me, which is in the server, I'm going to broadcast it to everybody using a name called update chat. It also has another part, which is the browser side, which is the client side. So this you need to include in your HTML, in your chat application in the browser. So when you include it, you will say io.connect to actually connect to the server that was listening here. So you'll say connect, and you will have again two pieces to it. So one is you will say whenever an update chat comes in, which is you can see here, if the server sends me any chat any information, do something here. So in this case, I'm using a really simple chat application. So if the server says update chat, and all I'm doing is I'm saying, okay, I'm going to append it to my conversation list. And on the other hand, if the user, like if you're logged into the browser, and if you emit a send chat, if I type a chat message, it will go back here to the server. It will say, okay, I'm going to listen to the send chat, and then I'm going to broadcast to everybody who is part of the chat application. So that's all there is to it. So you have two pieces of code, one in the browser and one in the server, and they both basically have the same same plug and socket kind of connection, and it will allow you to interact very easily. So I'm going to quickly show you how this thing would work by going to this app. So by the way, all these apps are in GitHub / Raja Rao DB, my name. Alright, so we are here now. So user 1. So I have a chat application here. If you guys, anyone wants to join, you can join. Just go to socket.io2.cloudfoundry.com just to show you how it would work. I'm going to open it in user 2. So you can see this chat is being sent back and forth from different people, right? So again, the code for if you think about it, if you want to build this same thing in different various other programming languages, you really need to learn a lot. So in this case, you just import Socket.io, and you simply create a function, like two functions, one on the server, one on the client. And on the server, you say, okay, I'm going to listen to anything that comes in, and I'm going to broadcast to everybody else. And on the client, you say, okay, if a user types something, I'm going to send it back to the server. So it's very, very easy to do all these kind of things. That's one of the reasons it's actually growing in popularity. That's about it. Just to summarize, in the beginning I talked about what Node.js is all about. It simply runs JavaScript. It kind of gives you an interface for you to build really highly scalable applications and very fast. And it uses JavaScript, so most of us are familiar with it. And the second talked about a lot of coding styles and patterns that you need to remember. In the third section, we talked about, how I couldn't cover the sticky session part, but I covered the hello world, how to connect to databases like MongoDB, how to use Express and Socket.io. Again, if you haven't done so, please go to cloudfoundry.com and register using a promo code Cloud today and try out Node.js. And that's pretty much it. Thanks everybody for joining. Hopefully you got some idea about what Node.js is. Look forward to do some more webinars in the future.
Thank you so much, Raja. And we have one question from our audience that we'll take now, and then we'll close the session.
Okay. So this question was asked by Mo. So he asks, as the number of clients increase, more JS code and callbacks are pushed to the event loop, which is single-threaded. On servers, do people typically run multiple node processes, each of which is single-threaded, or otherwise it seems one gets benefit for multi-threading from the V8 engine? Any thoughts? Any published data on the typical characterization of Node.js workloads?
Yeah, it's a very good question. I think Node.js, because it is single-threaded, so the idea it provides, one of the things I haven't talked about is it comes with a new library called cluster. So you can use the clustering, and then you can basically run a Node.js process for each course. Because it is single-threaded, it won't be able to, without clustering, it won't be able to use all the cores. So if your CPU has 4 cores or 8 cores, it will only be using 1 core. So in order to use multiple cores, you can actually spin up, the same processes in multiple cores. So just to scale it. But on Cloud Foundry, you don't need to worry about it. You can use instead, you can just simply use VMC instances and the application name and give like 100. It will automatically scale it for you. So clustering kind of does the same thing, and it provides similar messaging and stuff. But the disadvantage would be if one of these processes dies, then you would end up, kind of monitoring and taking care of restarting it and stuff. But rather, if you use Cloud Foundry's built-in scaling mechanism, then you could very easily scale up and scale down depending on how many people use it. And Cloud Foundry will take care of running it on different cores and stuff for you.
Great. Yeah, thanks again, everyone.